Now let us see the components of control system under feedback. Now let us see the types of feedback. What are the different types of feedback? One is positive feedback, another is negative feedback. There are two basic types. Now let us first discuss the positive feedback. The positive feedback is, this is the basic block diagram. In this basic block diagram, you all can see there are two main blocks having gain or the system function as G and another is H. This G is called the forward path transfer function or the gain, and the H is called the feedback path transfer function or the gain. Now these two comprises this positive feedback system via this error detector. This is the error detector which I have mentioned in the previous slide. This is error detector or the summing point, and this signal compares this component compares the two signal to get the actuating signal over here. So the actuating signal will be generated at the output of the error detector. This R of S is my reference. This is my B of S. It can be denoted by B of S, which is the feedback signal. When R of S and B of S is compared, that means they are compared to get a new signal as actuating signal, that is E of S, going into this block G, and the block G, after its necessary processing, it will be generate the overall output C of S. Now this block G is having the two things. One is the controller and another in it has the plant or process. So these two are combined inside this G. This is the generic block diagram. It is not a wholesome block diagram. So here the G comprises of controller and the plant. Now this is the block diagram of positive feedback control system, and the transfer function for this positive feedback control system can be derived as this. C of S is the overall response, R of S is the reference, the ratio of the two is called the transfer function. What it is? It is called transfer function. Why it is called transfer function? Because this is the basic characteristic behavior of this whole system, which entails whatever input is given to the system, it will generate a particular response, and the ratio of the two is the transfer function. That means this transfer function will be responsible, will be the familiarization to make ourselves understand that whatever is given as input, based on that what output we are going to get. So that means it is transferring something from the input in the output towards the output side. That's why it is such a mathematical function which is transferring a signal from input to the output of a system. So therefore, if the derived form is G by 1 plus GH, where this G and H is shown over this diagram, this G is the forward path gain and H is the feedback path gain, and they are always a function of frequency, and that frequency is denoted by S. So this S is basically the Laplace transform parameter we used to represent the system equations in a time domain form, and while we use the Laplace transform to convert the time domain form into the Laplace domain, everything in the equation, in the simple linear algebraic equation, everything comes as a function of this S. This S is called complex frequency. In a later stage, in some next lecture, I will be discussing the S-plane mapping of the control system. Then I will explain further regarding this S. Now this S is called the complex frequency. It has two components. One is sigma and another is j omega, and S is denoted by sigma plus j omega. Now what is sigma, what is j omega, I will be discussing in my next other lecture. So therefore, this S is such an independent variable based on which this G and H can be represented. So CS by RS is the transfer function of the overall system, and G and H I have already mentioned both are functions of frequency. Now let us see the next one, that is the negative feedback. So the negative feedback, similarly the block diagram is same. The only difference is block diagram and all the parameters shown are same. The only difference is here in the error detector of the summing point, this is minus. In the positive side, when we have discussed about the positive feedback, it was plus. Just note it kindly that it is plus. But while we are discussing about negative feedback, this is minus. So this is the only basic difference between the two diagrams. All the other things are same. The diagram, the parameters, the connections, everything is same. So another difference, because of this plus and minus scenario, the difference is in the representation of mathematical form. Previously it was g by 1 plus 1 minus gh, now it is g by 1 plus gh. Once again, this is the overall transfer function of this negative feedback, and g and h both are functions of frequency s. Now, objectives of feedback controls, objectives of feedback in control system. Now, it is the main theory part of the idea of using feedback in a control system. What are the objectives? You can see, you all can see that these are some of the main important objectives. Reduction of system error between the reference input and the system output. That means system error is the main thing of computation to understand the working of any control system. So therefore, reduction of system error is of utmost importance. Therefore, how it can be found, I have already mentioned, it can be found by the comparison of two signals in the error detector. One is reference input and another is system output taken back from through the feedback path. So therefore, the system error, once it is computed by the error detector, the final objective of the system designer is to reduce that system error. So it is the primary or the most important objective for using a feedback in a control system. In the second point, control variable supposed to follow the desired value accurately. That means the control variable, that means the value of the variable which we are getting as output response after all the things done through the working of the closed loop control system, that supposed to follow the desired value of accurately. Now what is desired value? Desired value is nothing but our reference, our benchmark, what we have set at the initiation of the system. That means when the system was initiated, we have set a benchmark which is called reference, and that is our desire. We always want that the output response must always follow that reference or the desired value. So this is another important idea or objective of feedbacks in a control system. Now the third one is reduction of the effect of external disturbances on the control variable other than associated with the feedback sensor. That means external disturbances may come in many forms, from extraneous signals, wear and tear of the system, environmental condition, aging of any particular component, whatever. So there by many means these external disturbances may come, and feedback sensors, that means for getting the sample data out of the output side given into the input side for the comparison with the reference input, we generally use some sensors. So sensors are used for taking the data, taking the signal sample from the output to get through the feedback path. So those are called the feedback sensors. So by way of this, some another noise or other disturbances may be introduced into the system. So other than those, any other type of sensors, other type of disturbances, if they are incorporated in the working of the control system, the idea is we have to reduce the effect of those disturbances other than the feedback sensors. Now the fourth one is reduction of the effect of variation in controller and process parameter in the forward path on system performance. That means in the forward path the controller or any system parameter of the plant or process under control, the variation from ideal situation, ideal value is not desired. So the objective of using the feedback is another, that the reduction of all those effects in those variations should be done, should be accomplished. So therefore this is another objective of feedback. And the final last but not the least, improvement of the speed of response as compared to response speed capability of plant or components in the forward path. That means the plant or the process which we are using, of which whose some parameters, some variables are under control, that capability of the plant or process, because every plant or process has its some inherent capability of response, of responding. Capability means speed of responding, how fast, how quickly it is adapted to changes. So over and above that speed capability, the speed of response of the improvement which we are thrusting into the control system by using the concept of feedback should be superseded. That means the speed of response for using the feedback should always supersede whatever the other speed capability of the rest of the system. So now these are the objectives of feedback in control system.